want to start from the homework? Let's go, Evan. 41. Okay, let me get the diagram here. Okay, 41. First thing, and this goes not just goes to Evan, but goes to everyone. Did you see the congruent marks that are already placed on the diagram? Okay, because that would have been, make sure that would have been helpful. BH by, ready? And in the, hopefully you noticed both the congruent marks on the diagram and the directions which said BH bisects EBC. BH bisects EBC. So which two angles up here would have been congruent? Frank? EBH, which I'm going to mark with 2 arc marks. And other one? FB. Oh, no, HBC. Good. Because BH was the angle bisector. Okay, everybody good on that? So there's 2 parts there. So hopefully you noticed that these 2 were congruent. That was already marked for me. And because BH bisects EBC, these 2 angles are congruent. So everyone okay before I get to 41? We're all in the same boat, because just because Evan asked it doesn't mean I'm going to ask other people questions. Okay, 41. ABF. So ABF, this angle right here is 8S minus 6. ABE. So ABE right here is 2 times S plus 11. Did anybody just distribute that right away? Is that okay if I do that? So get 2S plus 22. And what am I solving for 41? EBF. Okay, ready, Evan? What do you know about these 2 angles right here? They're congruent, so I can set 2, if that's 2S plus 22, that's also 2S plus 22. Good. And they add up to what? Okay, 4S plus 44. And that's equal to the whole angle, which I was told was how big? 8S plus minus 6, yep. All right, so I move the 4S, I move the 4S over, I get 4S. I move the 6 over, I get 50. S is equal to a little more than 12, 12.5. Okay, 12.5. I don't think I was asked to solve for S, though. I was looking to EBF. So EBF, where do I plug this 12.5 into? 2S plus 22, because these 2 are equal to each other. So I plug that 12.5 in for 2S plus 22, and I should end up getting 47. Good? Okay. Where else do you want to go? Was that it? Are we doing all right with this? Because I'm going to add on to it today with some new angle topics. So we're all good? No more issues from the homework? Going? Okay, let me see it real quick, and then we got to get down to business. Okay, day 7, relationships between angles. First topic, adjacent angles. Adjacent angles. 2, ready? 2 angles have the same vertex and they share a side. Have the same vertex and they share a side. I'll show you what it means in a second by they do not have any interior common points. All right. So for A through D, this is not a multiple choice. We're going to go through each and say, are angle X and angle Y adjacent to each other? They share the same vertex. They have a side in common, and there's no interior points that they share. So let's look at A. Do we think those are adjacent angles? Adjacent angles. Well, do they share the same vertex? Angle X and angle Y, do they share the same vertex? Yes. Do they have a common side? Do they have a side in common? Yes, this one right here. Now, here's what it means by no interior points in common. If I take angle X and put an interior point there, is that also an interior point in Y? No. If I take one and put one in Y, let's put one right there. Is that also an X? No. So do you see what they mean by no interior points in common? Okay, so these 2 right here are adjacent to each other. They are adjacent. What do you think about the next pair? And if you're going to say no, make sure you back yourself up with something that it doesn't follow here. All right, something that it does not follow. Go ahead, James. Correct, not adjacent, because look, here's the vertex for y, here's the vertex for x. No good. Everyone see that? Okay, so not adjacent. Okay, here we go. Let's roll. C, what do we think? By the way, just so you know, this is angle y right here. This is angle x right here. Let me do different colors. Here's angle x. Here's angle y. What do we think? Adjacent or not adjacent for this one? Adjacent or not adjacent? Here we go. What do we got? 3. What do you think? Anybody? 3? Everyone's here today, so there's 3 somewhere in the house. Hi. Adjacent. Hey, they share a common side right here. They share a common vertex right here. Ready? Is that point also in y? Nope. So it's adjacent. Okay, quick clarification on D. Everyone see this right here? That is angle x. This is angle y. So the orange is angle x, and the blue is angle y. So that might be a tough one on here. What do we think? They share. Okay, here let's go through our criteria here. They do share the same vertex. Everyone agrees? Nice. They do share a common side right here. Right? If this is angle x and this is angle y, they share a common side. But what's the problem? Ready? I'm going to put one right here. Does everyone see that that's in y? And it's also in what angle? X. So no go. Not adjacent. Okay, everyone all right on adjacent angles now? Identified them. Questions? Moving on. Let's roll. Complementary. You guys always maybe got these confused, complementary versus supplementary. Complementary to, this is the key right here, and you may want to underline this. 2 angles that add to 90. 2 angles that add to 90. All right, cannot be more than 2. So ready? $40 and $50. Here's where you're going to start seeing now that you're in high school and honors geometry. Does everyone see one of my second diagram? Angles 1 and 2 would be complementary. How do I know they add to 90? What tells me it's 90? Joanna? The square symbol. Yep. Okay, so start getting used to it. And ready? Whoa, here you go. Give me another term for angles 1 and 2. They're complementary and just went over it. Adjacent. Yes, complementary and adjacent. Okay, but again, I'm going to stress this and make sure it's 2 angles who add to 90. Well, what's it called if 3 angles add to 90? Anybody know? 3 angles that add to 90. That's what it's called. All right, we don't have a special name. All right, complementary is reserved for 2 angles. Supplementary, 2 angles again that add to $1.80. Yep, so let me give you 2 diagrams here. Say that's 120 and say that's 60 degrees. Those 2 are supplementary. All right, those 2 are supplementary. And let me give you the advanced diagrams that we're going to start seeing. Why are 1 and 2 supplementary? Why do 1 and 2 add up to 180? Rose? Just they add up to a straight line. What do you know about a straight line? Measures 180. Yep. Give me another name for angles 1 and 2. They're supplementary and they're adjacent. They're supplementary and they're adjacent. They're supplementary and they're adjacent. Why am I harping on this? Because if they're supplementary and adjacent, we don't say supplementary and adjacent anymore. We got a new term for it. Brand new term, everybody. And that's linear pairs. Okay, linear pairs. If two angles are supplementary and adjacent, we refer to them as linear pairs. Again, the word linear has the word, don't say ear, line in there, yes. Two angles that form a line, all right? So let's take a look at A, B, and C. Are these linear pairs or not? Let's find out. What do we think about A? Are 1 and 2 linear pairs, adjacent and supplementary? What do we think, Frank? No. They are what? They are adjacent, but do they form a straight line? No, they do not. So not a linear pair. What do you think about B? Are those two a linear pair? Absolutely. Adjacent and form a straight line. So those are linear pairs. And what do you think about 1 and 2? Are those linear pairs? That looks kind of crazy, huh? Well, first of all, are they even adjacent? They don't even share a common vertex, so we can stop the discussion now. I don't care if they add to 180 or not. They're not linear pairs because they're not adjacent. All right. Questions? Comments? Any concerns? Linear pairs. Adjacent and? Adjacent and? Adjacent and? Okay, again, why am I harping on that? Congratulations, you've arrived at your first theorem of the year. Has anybody ever heard that word theorem? Probably Pythagorean theorem, right? It's a fact. All right, it's a fact. Here's what we just learned about linear pairs. You finish the theorem for me. Finish this fact about linear pairs. Linear pairs are, and I don't want adjacent. That should be a big hint. Linear pairs are, and I don't want adjacent. They are adjacent, I get, yep, but that's not the word I want here. Linear pairs are, yes, they're adjacent, but they're also, Juliana? Supplementary, there we go. There's our first theorem. Linear pairs are supplementary. Congratulations, everyone. Okay, stop before we move on. Can you visualize what a linear pair looks like now? And you know they're supplementary, which means what? They add to 180. Okay? Okay, one more topic before I let you go on your own. Vertical. Anybody heard of vertical angles before? Vertical, yes, a couple of you guys. All right. Here's basically what vertical angles are. You draw two intersecting lines, and they're opposite each other. Okay? Draw two intersecting lines, and they are opposite each other. Those are vertical angles. All right? Two lines intersecting each other, and the angles are opposite. So take a look at A. Two intersecting lines, are these angles opposite each other? No. So these are not vertical. But I'm going to challenge you now, honors kids. They're not vertical, but they're what? Don't say anything. Think about it. Give me a term we've already talked about today. They are not vertical, but I can call them blank. Let's do this. 28, going all the way to the end. So, okay, supplementary, correct. Let's keep building now. Supplementary, give me another term. Go ahead. Linear pair, perfect. All right, that's where I want to get you guys to. Yes, they're supplementary, but I need you to get to that linear pair level. Okay, does everyone see why they're linear pairs? We're good. Okay, B. Are those two vertical? Well, there's a problem right off the bat. Are they intersecting lines? Yeah, we talked. That's never going to be a line in here, right? Okay, so no, not vertical. How about C? Are those vertical angles? Two intersecting lines and they're opposite each other. And we have to have a yes sooner or later, right? Can't have all three no's. So yes, these are vertical angles. A fact about vertical angles. I am not going to give it to you. You know why I'm not going to give it to you? Because what class are we in? Honors. You're going to find out the settle down, Joanna. Your classmates are going to find out for themselves. Okay? Do you know it already? Great. Settle down. You ready? You're going to find out yourself now. Don't do this. I'll just do it up here, and then you guys tell me the fact about vertical angles. Everyone ready? See my two intersecting lines? Frank, give me an angle measure for one of these. Just any angle measure, obviously below 180. 60, you got it. So I'm going to put 60 there, guys. Can you guys fill in the rest? Ready? If that's 60, what's the one right next to it? Because they are, sorry, supplementary linear pairs. So if that's 60, what's the angle measure right next to it? $120. Everyone agree? If that's 120, what's the one right next to it? If that's 60, what's the one right next to it? You got a fact for me about vertical angles now? Go ahead, Joanna. I won't steal your spotlight anymore. Vertical angles are congruent. Perfect. Does everyone see that? Vertical angles are congruent. Not supplementary. Vertical angles are congruent. Bam! Nice. I like it. How you guys doing, all right? Because I believe, what do we got coming up next? Oh, geez. Got one more. Perpendicular lines. Two lines that intersect to form right angles. Can you draw that for me? Two lines that intersect that form right angles. Go ahead. Two lines, make them intersect. They form a right angle, which means how many degrees? 90 degrees. And make sure, hey, you guys should be able to put some markings on your diagram that says these are perpendicular because you know the 90-degree symbol now. Good, good, good. And I saw a lot of you put the 4 boxes. That's fine. You only need to put 1, though. Here's why. Ready? Here's why you only need to put 1. What type of angles are these? Watch it. Oh, look how all this is coming together. What do you know about vertical angles? So that's 90. What type of angles are these? Linear pairs, so they're supplementary. So if that's 90, this is also. So that's why you only have to put 1. Okay? It's amazing how all this geometry comes together, huh? Yeah, I know you're excited. We're not done, though. We're not done with this. Let's label one line AB, and let's label one line CD, because like everything else we've been doing this year, you need to be able to not just tell me, but write it as well mathematically. So how do I show that line AB is perpendicular to line CD? Dropping any knowledge on the perpendicular sign. Ooh. Nobody? Hi. Equal. That's the equal sign. Why would it be the perpendicular sign? Embarrassing. What else do we have? Anybody else? All right, I don't have time here. So ready? The upside down T. Oh, yeah, I knew that. No, you didn't, because you would have told me. There you go. That's the sign for perpendicular. Okay, sign for perpendicular. Everybody good? Okay, usually I would let you guys try this, but I don't have time just to let you go here today, so I'm just going to start asking people. We up for this challenge? Okay. Complementary, meaning what? They add 2 angles that add to 90. So I want another angle that with BOC adds to 90 on that diagram. All right, take a look at it. All right, I'll choose a number in a second. Another angle that I could add to BOC that would give me 90 degrees. Take a look at your diagram. Take a look, I got the right angle in there already. Okay, so give me another angle that I could add to BOC that gives me 90. Not more than 90, exactly 90 degrees. What do we got here? Oh, 20. What do we got? Great job. Angle AOB. Everyone see that one? This one right here? Because this angle, COA, is a 90-degree angle. And to BOC, I would need to add AOB. Perfect. Nice job. How about supplementary? Adding to what now? Adds to 180. BOC. Be careful here. BOC. So I'm taking BOC again. What angle would I add to it to get supplementary, aka a straight line? So think to yourself, all right, what angle would I add to BOC to get to a straight line now? Let's see what we got. 18. What do we got? COE. Not bad, guys. I like it. You guys are on fire. Guess you are honors kids, huh? Everyone see that one? I'll highlight it in case you don't. Here's BOC, and here's COE, the one you just gave me. This forms a straight line. Okay, forms a straight line. And then adjacent, adjacent and congruent to AOC. So here's AOC. Give me one that's adjacent and congruent. Adjacent next to, and it's got to be congruent to AOC. Not too bad, I hope. Here we go, 24. DOC, you got it. The other right angle that's next to it. How we doing, kiddos? We all right? Going? Going too fast? Soaking this all in. It's a lot. We go quick here. Whew. Ready to use the diagram now? Let me just read it first. Make sure I don't have any congruent angles. Nope. Okay, I don't have any congruent angles or supplementary or complementary, so we're on our own. All right, AOB, x plus 3. So x plus 3, AOB, follow the letters, x plus 3. AOC, 2x plus 11. So AOC, this angle here, 2x plus 11. And then BOC, 4x minus 7. Solve for x, find the angle measures. Okay. I need obviously an equation to set up here based on all that information. How about an equation to set up? What do you got for me? 23. There you go. He's taking these two angles and saying, all right, if I add them up, I get the whole angle, which I know is 2x plus 11. Go ahead, kids, get to work. And then once you find x, plug it back in to find all three angle measures. We're getting 5? X equals 5? Okay, go ahead, go through it with me now. 14, what'd you find for the angle measurements? AOB? 5? Nobody got 5? Okay. Or 1. Oh, you can throw a curveball. Go ahead. There you go. And just a quick check. These two should add it up to AOC, correct? All right, there we go. Questions? Yeah, everyone's favorite. Some word problems. Yeah, buddy. Here we go. Everyone's favorite. There it is, right on time. All right, pick up for some of you. Here we go. Ready? Ooh, 2 angles are complementary. Stop. What do I know? These 2 angles are going to add to 90. Here's what I like to do. As soon as I read that, I'm going to say 2 angles that add to 90. Now I have no idea what I'm going to put in there, but at least I know there's 2 angles that add to 90, so I got the kind of the foundation of the equation ready to go. And the degree measure of the smaller angle is 50 less than the degree measure of the larger. Okay? Usually all these problems, we're going to have to call the first angle what? X, and then build off that. All right, so we're going to call one of the angles X. Degree measure of the smaller angle is 50 less than the degree measure of the larger. How do I write 50 less than that? 50 less. Go ahead. What do you got, Evan? X minus 50. So one of the angles is X. The other angle is X minus 50. Some of you guys are probably used to let statements back in the middle school, maybe. Let statements. Okay, I don't care. I don't. As long as at the end of the problem you tell me the larger angle equals this, smaller equals this, I don't need let statements. Is everyone all right on how I set up my statements here? Hi. As long as you keep the smaller and the larger separate, yes. Okay. So here we go. Everyone can solve this, no issues. 2x minus 50 equals 90. 2x equals what, $1.40? X equals 70. What's that 70 represent? The larger angle. So just make sure you tell me. Don't leave x equals 70 because I don't know which one is which. Larger angle equals 70 degrees. And if you looked at the problem, it said find the degree measure of the larger angle. So that's as much as I need to show. If you want to try to be a hero and show me the smaller, sure. I'm sure I'll write a nice note on your test saying, yeah, great, way to go. Nobody cares. Okay. Everyone all right in here? Okay. And how about 6? 6 we probably haven't seen before. 2 angles are, meaning they're going to add to. Ooh, here's a new one. The ratio of those 2 angles is 7:2. Woohoo. Okay. And they add to 180. So it could be what? 7 and 2. Could be 14 and 4. Could be 21 and 6. Everyone seeing where I'm getting those numbers from? So I'm saying to myself, all right, well, it could be 7 and 2, but that doesn't make sense, right? Because it's got to add to 180. I guess it could be 14 and 4. It could be 21 and 6. What do I keep doing here to get these values? Well, I'm multiplying the 7 and 2 by 2, and then I'm multiplying it by 3, and I could multiply it by 4, 5, and then keep going and keep going and keep going to see when it multiplies or when it adds to 180. But that could take forever. So instead, what I'm going to suggest you do, and this is what we're going to do all year long, anytime we're in a word problem where we have a number and a ratio, we're going to make one angle 7x, and we're going to make the other angle 2x. We're going to find out what we need to multiply by instead of all this trial and error here. Does everyone see where I went here? I multiplied by 1. I multiplied by 2. I multiplied by 3. Okay, now I'm really going to find out what do I multiply by setting up this equation. So anytime I have numbers in a ratio, going to put x's with them. 9x equals 180. X turns out to be 20. Oh, that's what I had to multiply by, was 20. It would have taken us forever to get there, right? Doing it by trial and error. Find the degree measure of each angle. So what do I do with this 20 right now? Because one angle is not 20 degrees. Remember, these are the two angles up here. What do I do with that 20? Here you go, 19. What do I do with that 20? Okay, so let's start. One angle is going to be what? 140. And again, how did she get that? She said 7 times 20. Yep. And the second angle? Yep. And quick check, these two angles better do what? Add up to 180, which they do. Yay. Everyone, yes, sir. So you're just reducing the fraction. That's all you're doing. Like you're just taking 7 over 2 and saying that's the same as 3.5 over 1. Yeah, that's fine. Same thing. Okay. Any other questions? This I will let you go on your own right now. Okay, within your group, go ahead. I will post the answers up here so you can check them as you go along. This will probably take you right up to the bell. Again, you work with people around you. Feel free. Take a glance up here just to make sure you're getting the correct answers.